Okay, so welcome again to EM1202. So this is Integral Calculus. And again, for those who don't know me yet, so I'm Engineer Oliver Dave Maguyon from the Civil Engineering Department. And I'll be your instructor for the rest of the semester. Okay, so let's begin. So the outline for this discussion for today is we'll be having the introduction for the integral calculus, or what we call as the antiderivative. Then after discussing the basic stuff, so we'll proceed with the basic formulas and then explaining some of the examples that will be dealing with the formulas. So for the transcendental functions, so there will be four, and this will be discussed this Friday. So transcendental functions are functions that are not algebraic. So of course we have the other functions: trigonometric, inverse trigonometric, hyperbolic, and exponential. So this will be tackled this Friday. Okay, so start off. So in differential calculus, so a derivative or differential is obtained by differentiating a given function. So for example, we have x cubed plus 4. So what you did in calculus 1 is you take the derivative of such function. So ang answer na niya is, for example, we take the derivative. So d over dx, diba? Mauna siya ang proper way of getting the derivative. So may mo siyang kuan, diba? Um, nasa, oops, isa. Okay, so that will be x cubed plus 4, diba? And then the corresponding answer will be, so 3x squared plus 0. And then the final answer will be 3x squared. Okay, so that will be your derivative. Now, the main objective of your integral calculus or your integrals is for a given derivative, let's say 3x squared. So we need to go back to its original equation, which is x cubed plus 4. So that's the objective of your integral calculus. So more likely what you need in calculus 1 is just the derivatives topic. So as long as you know how to derive, so the reverse process of it is just the integral. Okay. So the derivative of the given equation is 3x squared. So let's say wala ta kabaw aning x cubed plus 4. We don't know that the original equation is x cubed plus 4. Okay. So let's say we don't know that the original equation is not x cubed plus 4. And and then what is given to us is only 3x squared kanira. So if you want to know the original equation, so by guessing, we can say that the equation is x cubed, di ba? So possible equation for the derivative of 3x squared is x cubed because its derivative is also 3x squared. So the same siya og derivative sa kaning given function earlier, di ba? So again, if you don't know x cubed plus 4 is the original equation and you're only given this derivative 3x squared, so if you want to know the original equation, so by guessing, so we can just say that the original equation is x cubed, di ba? But dili siya mo ang original. Now, if you try to guess other possible equations of this derivative, kani siya. So there are other possible equations, di ba? So we can say kani gyapon, di ba? X cubed plus pi. So this is also a possible equation because the derivative is also 3x squared because pi is constant. So also x cubed plus 5, the derivative is 3x squared. And x cubed minus 2, the same derivative, 3x squared gapon siya. So notice that we have a pattern as long as your x cubed is paired with a constant, so its derivative is always 3x squared, gani siya, di ba? So by that, we can say that that the given equations have different constants, but it results to the same derivative, 3x squared. So maskin x cubed plus 1 million pa siya, the resulting derivative is still 3x squared. Okay? So, so we can conclude that upon derivation, so we can have a general answer of integration. So for example, we integrate 3x squared. So we can say that the general answer is x cubed plus a given constant. Diba? Any constant is possible in this equation. So we can have x cubed plus c. Okay? So usually when we revert back to its original equation, and since we don't know what the original equation is, so let's say we can get the specific variable that kaning x cubed baron, but we cannot get the specific value for the constant. So um it, so if you ask me how do we get the constant, so you'll get this one in your next subject, which is differential equations. So next school year. So for now is we'll just learn how to integrate because in differential equations you'll be using the techniques of derivative and integration in the process of getting the differential equation. So combine na ang both techniques. So that's why I suggest that you master the derivatives, then you master the integration techniques as well because it will still be useful in your advanced mathematics. Okay? So by definition of your integral calculus, so a given function, so that's the big f of x, is an antiderivative of the small f of x. So what do you mean by this first statement? Is that antiderivative is also what we call as the integral. Okay? Integral. So the big f of x is the resulting integral. So muna siya itong resulting integral. And then kaning atong small f of x is your given derivative. Di ba? Atong let's say muna siya ato ang derivative ni siya. So muna siya ato ang 3x squared earlier. And muna atong resulting integral kato ang x cubed plus c. So muna siya. So next statement, if f of prime of x is equal to f of x for all of x in the domain. So what do you mean by this statement? Kani siya is that if we try to derive the kaning resulting integral, di ba, big f of x. So we derive this one because it's prime, di ba? So for example, we try to derive x cubed plus c. So the resulting answer is kaning ato ang 3x squared. Na kay bali-bali raman siya, di ba? So muna siya ang nakanindot ani nga subject because after integration, if you want to verify that your answer is correct, so you can just derive your final answer, and if it goes back to the given equation, So meaning your answer is correct. Okay, diba? F of x, small f of x. Okay, so the set of all antiderivatives of f is the indefinite integral of f. So indefinite integral because there's no limits of integration. So what we mean by limits, so later on in the later part of our first half of the semester, so we'll be dealing with definite integral. So um, if you observe your calculator, so na-function din sa calculator kaning snake, kaning bitin, kaning integral sign, then na-box diya sa lower and upper. So lower limit, upper limit. So that's the purpose of the limits. So karon is since we are still dealing with the different techniques of integration and we don't know we're not yet interested in the limits, so we call it as indefinite integral. So meaning plain na siya nga kuan, plain na nga snake. Okay? So the symbol is defined as the integral. So if you read this particular equation, so the integral, this is the integral symbol, kaning murag bitin. So the integral of f of x, so f of x is the integrand with respect to x. So dx is the variable of integration. So whatever variable is being asked here, so muna siya yung integrate. So the same as your partial derivatives wherein, for example, na mo x, y, z nga equation and then you're just partial deriving in with respect to z. So ang z ra yung ikuan. So the same goes for your integrals. So you only integrate what is asked in your equation. So if with respect to x, po ang atong integrate. Okay, so the resulting equation is this particular integral, big F of x plus c. Okay, so if we define the different parts, so kanito bitin is the integration symbol or the integral sign. It's also called the elongated S, and it's the first letter of the Latin word summa or sum. So ano sum man because one applications of integral calculus is summing up areas. So summing up areas, okay? So f of x is the integrand. And then the big F of x is your particular integral. So dx is it indicates that x is the variable of integration. So again, as what I have told you earlier, it could be any other variable as long as o kung sa may present diya sa equation is mo na inyong i-integrate. And then c is the constant of integration or the arbitrary constant. And combining the f of x, the particular integral, and the constant is your value of your indefinite integral. So muna siyang mga different parts of your integral equation. So instead of calling this one the derivative, so we call this one as the integrand. Integrand na siya. So ganina is para mahibaw lang mo nga coming from the derivative, we go back to the original equation. So muna siyang point sa integral calculus. Okay, so questions or clarifications? Okay, so let's proceed with the next. So the process of finding the antiderivative is called antidifferentiation, and it's also called integration. Okay, so muna siya di ba ang kon. So sumpay-sumpay na siya ako rang gilay-lahi og pagbutang na. And this one is so integration is finding the function of the given derivative or differential. So let's go to the basic formulas. So the formulas that I'm going to show you is u and v are differentiable functions of x. So what do you mean by this one is ang atong u, it could be any function, let's say x cubed plus 4 baron na or ang inyong v baron in terms of x, di ba? Okay, button there is function of x man siya. So u and v are functions of x. So let's say v is 3x squared baron na. Okay. So letters a, n, and c are constants. So these are the 5 basic formulas. So the first formula, so if we try to break down the formula, so this one is just the derivative of a constant. So derivative of a constant. So ano constant man? So again, if you try to identify the different parts of your equation, so this one is the integral sign. This one is the variable of integration, u, di ba? So ang atong integrand is kaning 1 dire. So invisible lang siya because dili man kita used to putting 1 in the equation, di ba? So manamay mo siyang u plus c. So this is the answer to your first basic formula, u plus c. So again, if you want to verify that your answer is correct, okay, since it's just reversible, so if you want to derive u plus c, so derivative of u is 1, di ba? Derivative of constant is 0. So 1, the same as the original equation. Okay, so for the second and third formulas, so most likely these are not formulas but properties. So what happened in the second and third formulas is that kaning second formula is we just distributed the dx to the terms, resulting into two different integrals sa right side. Okay? So ano na may c dire? So again, if we take this one individually, so the integral of the first equation is we have a resulting one constant, di ba? And then sa second nga integral is we have another resulting constant, the second constant aside. Now since these are both constants and we don't know the value, so we can just combine them into one big constant, kaning c, outside the equation. So muna siyang pag-determine sa inyong constants. Okay. So another property is again if you have a big constants, so you can just factor the constant outside the equation. So for example, kaning a. Na, so factor out the constant outside the equation, and then you can deal later with the constant after integrating the equation. So muna siya au plus c. So if you ask me, ngano walay a ang c? So again, if we try to break down the equation, so again, that will be a, then u plus c, di ba? Let's say muna siyang answer. So upon expanding, so what you will get is au plus ac. Now notice that since a and c are both constants, so you can just combine them into one constant. So we can't combine a and u because u is a variable. Okay. So the fourth formula is the exponent rule of integration, or the exponential rule of integration. So it's just the reverse exponential rule in the derivatives. So derivatives ninyo is kuan man siya, di ba? N u n minus 1 du, di ba? So we bring down tawag n, making it a coefficient of the variable, and then we took one of the exponent sa inyong function of u. And then we take the derivative of u after. So that's the derivative. Now notice in your integral calculus, so since we took one in the derivatives, and then we're reversing back to the equation, so moata po tagwan, di ba? So moata tagwan sa exponent. And then, since we have this coefficient na atong gi-bring down coming from the exponent, so muna natay n plus 1 sa denominator to eliminate the n na gi-bring down earlier sa atong derivatives. So sige lang, ato na siya ma-appreciate later once we go to the examples. So di ba, makita rin ninyo nga, it's just the reverse process of the derivatives. So there's nothing new to, marag yung new nga I-learn there is just the techniques, because it's just a way of verifying, it's just a reverse process of your earlier course. Okay, so lastly is your logarithmic nga kuan. So in differential calculus, so this one is basic. So if you have ln of u, so the derivative of this one is du over u, di ba? So if we try to integrate it, so reverse process, di ba? So ana na siya. And unfortunately, wala tay integral sa ln. So mura na siya ang wala diri sa kuan. Okay. So for you to appreciate the different formulas, so let's go to the examples. So we're going to discuss 10 different examples, and I hope we can finish by 10:30. Okay, so as you can see, basic formulas, basic problems, then we go to the difficult ones. Para natin transitioning sa ato ang examples. Okay, so let's start with a very basic formula. So again, if you read the equation, this will be the integral of 5 of x with respect to x. So that's a proper way of reading the integral equation. But again, since kuha naman ta later on, naspasa naman ta later on, so pwede po integral 5x dx na. Mas at least kibaw mo on how you pronounce correctly your given equation. Okay, so if you observe the given integral, so we have 5. So this one is a constant. So again, your 5x is the integrand, but we have 5 as the constant. Again, the variable of integration is x. So again, we can take 5 outside the equation. So integral. So practice na mo og drawing og bitin. Then x dx. Okay. So in the basic formula, so this one is we can use the exponential rule, because the exponent of x is to the power of 1, di ba? Nya 1 ay lain. So meaning you can integrate it. So we have, so x, so ako lang sa i-basic ha, x 1 plus 1 all over 1 plus 1. So again, we have plus c, di ba? Then expanding the 5 to the given equation, so 5x squared all over 2 plus 5c. Again, 5c is just a constant gapon. So your final answer is 5x squared all over 2 plus c. So this one is your final answer. So CC pa kayo, no? So again, if you try to verify your answer, you want to derive your answer. So the derivative of 5x squared over 2 plus c. So meaning may mo siyang 5, so bring down 2, then x, then 2 minus 1, that's 1, di ba? Then the derivative of x is dx, di ba? So constant ra gyapon all over 2 plus c. So cancel out 2. Then gani siya kay 0, di ba? 0 din ni siya. So the answer is 5x dx. Oh, na siya dx today. So the same as the given equation. So that's how you verify your answer. So again, I suggest that you don't do this once we go to the later topics. Okay, of course, if we'll be dealing with the advanced functions such as your inverse, your hyperbolic functions, your exponential functions. So, of course, kailangan sa mog high-end na kuan sa differentiation techniques. Diba? Na. So, of course, magkalisod ang topic, magkalisod po ang way of verifying the answer. So, this is since basic man ta, so we have the basic derivatives to help us verify our answers. But once we go to the higher topics, inverse, trigonometric functions, so medyo lisod-lisod na po siya i-verify, di ba? Kay walang taas-taas po to ang process of getting the derivatives for your inverse trigonometric function. Okay? So next example is we have integral of x cubed plus 4 with respect to x. So again, using the basic formulas or the basic guide, so distribute dx to each term in the given integrand. Okay, so we have x cubed plus x cubed dx plus 4 dx. So again, I'm just going to show you the step-by-step process lang. So this one is, so let's, before we integrate, so let's try to bring outside the constant. So integral of dx. Okay, so in the first equation or in the first integral, so if you try to search online, so there are many ways to pronounce integral. So na yung mga reference nga integral ana integral ana. So depende ano yun sa inyo pagkuan. Okay, so in the first equation, so we can use the exponential rule. So x cubed, so plus 1. And then the denominator is a whole number, 3 plus 1. So again, we have one constant plus c. Okay, so times 4. Then again, the derivative of dx. So again, we have a 1. Wow. Invisible 1. So the derivative, the integral of dx is x plus c. Okay, so finalizing your answer. So x to the power 4 all over 4. So plus c plus 4x plus 4c. So the final answer is x to the power 4 all over 4. So plus 4x. So again, instead of 5c atong ibutang, di ba? C plus C plus 4C. So, C lang. Na. So, syaro magkasakit mo aning kuan subject ka, di ba? Sira mo C, vitamin C. Mura dyan na inyong iwan. Asa ma-remind mo sa inyong vitamins everyday sa itong na subject ka. Okay, so again, if you want to try to get the verification for your answer, so just derive the final answer. So derive this one. So try reviewing it later. Okay. Okay, so next is we have the integral of 3t squared plus 2 t over 2 with respect to t. So again, t na sa nga variable, di ba? Di na punta x nga variable. So distributing to both terms. So we have integral of 3t squared dt plus integral of t over 2 dt. So further simplifying before integrating. So 3 outside the integral symbol, t squared dt plus, so t over 2 is 1/2 man na siya, di ba? So 1/2 outside the integral symbol, t dt. Okay? So we can now integrate. So that's t. So pili na to i-shortcut na lang kay kibawa na mo sa process, di ba? So t cube all over 3 plus c. So again, if kibawa na mo sa process, so pwede ra siya walay c na lang ana. Later lang nyo i-add ang c at the end of your answer. So plus 1/2. So this will be t squared all over 2. Then again, then nyo ibutang inyong c, di ba? So kanina, ang purpose ato nga nagsigog butang og c para ma-remind lang mo nga originally for each integral equation na siya corresponding value of c. And then we just combine it later at the end part of the final answer. Okay, so simplifying your answer, so you have t cubed, so cancel out 3, di ba? So plus, so multiplying fractions, so the numerator against numerator, denominator against denominator, so t squared all over 4 plus c. So this one is your final answer. So again, if you want to verify your answer later on, or if I'm filling out later, so you can try deriving the answers. Okay. So let's proceed with the next example. So question so far. Okay, so magsisiyo pa kayo, no? Okay, so next is the integral of x to the power 3 halves minus 3x plus 14 with respect to x. So again, distribute 3 times. So distribute ani. So again, if paspas na kayo mumukuhan, let's say so sige lang, you can practice kay tagata mo problem set man. So x cube, x to the power 3 halves. So minus 3 integral of x, ana, di ba? If paspas na kayo mo, ana, pili mo yung mag-shortcut gamay. Matili, totally shortcut nga sa kaning given ko, dito din answer, ana, di sana mausad. So 14 integral of dx. So next is integrating. So x to the power of 3 halves. So 3 halves plus 1, 5 halves, di ba? All over 5 halves. Minus 3, then x squared all over 2. Then lastly is 14x plus c. So you might wondering ano paspas kay ko naka-add og fraction. So I'll give you a technique kung saan na siya pag-achieve. Kay wala ba calculator sa midterms? So 3 halves, di ba? Plus 1, di ba? Na plus 1. So in basic terms, so you can just do the crisscross method, di ba? Kay kaning 1 is pili siya may mong 1 over 1, di ba? Kay it will result to 1 gyapon. Na crisscross na siya, crisscross method na siya. Muna ko nakatunan sa akong elementary. Na so kani una, di ba? Or bisag asa na basta panong babaw. So 3 times 1 plus 2 times 1 all over 2. So 3 plus 2, 5, di ba? 5 halves. Okay, so another technique is kanang mental math. So 3 halves. So plus 1 man, di ba? So I'm going to observe the denominator sa pikas. Na since 2 man siya, nya dapat ang ako ang resulting akuan is 2 sad sa pikas, di ba? 2 po diri para na ko similar fractions. Now, dapat 1 man akong whole number, di ba? So, unsa may value sa numerator para ma-1 ang value, equivalent gyapon siya sa 1. So, obviously, it's 2 gyapon, di ba? Kay 2 over 2 is 1 man. So, now, since I have similar fractions, so 5 halves it. So, di ba? Mas dali siya. So, it's applicable to any whole number. So, let's say, ato batakang number, 4 baron, di ba? So, again, looking at the denominator, so 2 man siya, di ba? So, para ma-achieve na ko ang kuan, ang iyahang similar fractions. So, unsa man ang value sa numerator para makakuha ako og whole number nga 4. So, 8, di ba? 11 over 2. Yeah, if crisscross siya, so that's 3 times 1 plus 4 times 2 all over 2, di ba? 11 over 2 gyapon siya. Na, so, muna siya mga kuan, mga kay base nalimot mo ba og saan pag-add og fractions, so at least namoy easier way to handle fractions. Kay labi na once we go to radicals, so kanang mga square roots, yeah, the only way to deal with square roots is to transform them into its corresponding exponential form. So square root, may mo siyang x to the power of 1 half. So muna siya yung mahitabo later on. So going back to the answer, so if we simplify this one, so may mo na siyang 2 times x raised to 5 over 2 all over 5. So ano man ni siya? So let's try to explain this one. Ano na mo siyang inana? So lying color na sad. So notice nga x, so in basic terms, in basic kanang algebraic nga division, so x to the power of 5 halves divided by 5 over 2. Diba? Mo na siya sa kwan. Now, the rule for dividing fractions is we get the reciprocal, then we multiply it to the first term. So, okay, so x raised to 5 halves, then multiply na siya, di ba? Then we get the reciprocal of this one, 2/5. So that's why the answer is 2x raised to 5 halves all over 5. So I suggest if maglisod mo og simplify, so go very basic with the process kay para ma-sure niya ang answer. So the second term is 3x squared all over 2 plus 14x plus c. So muna siya inyong final answer. Okay? So questions? Or okay. So let's go to the next example. Okay, so muna siya ang yung ganina. So natin radical, di ba? So again, distribute. So we have integral of 1 over t squared dt plus integral of the square root of t dt. Okay? So kani siya, since we don't have any formula for 1 over the variable to the raised to any power, so what we normally do is we try to get the kanang dili fraction nga form aning exponential form ninyo. So what happens instead of 1 over t squared, so ato siyang ibalin sa numerator para dili kay siya lisod i-deal with kay fraction siya. So it becomes t raised to negative 2 dt. So pili siya na, di ba? And then the other one, the second term, so for us to be able to deal with the radical, so we convert it into its exponential form. So that's t raised to 1/2 dt. Okay, so we can now use the exponential rule for integration. So as long as your exponent is not equal to negative 1, so di ba katong formula is u to the power of n plus 1 all over n plus 1. So imagine if our value of n is negative 1, so u negative 1 plus 1 all over negative 1 plus 1. So the resulting answer will be u to the power of 0 all over 0. And that's 1 over 0 because any number raised to 0 is 1. And since 1 and any number divided by 0 is undefined. And walay undefined na answer sa inyong integral calculus. Okay, diba? Going back to the definition, the integration symbol is the first letter of the summa. Diba? So meaning sum. So there's no point in summing up undefined na mga values. Okay? So this one is t raised to negative 1 all over negative 1. Then this one is t raised to 3 halves all over 3 halves plus c. So again, if you try to review your fractions, so you can try to simplify things much faster. So t to the power of negative 1 plus 2t to the power of 3 halves all over 3 plus c. So usually this answer is already correct. Kani siya. Ayay. So kani siya is correct na siya. So if you want to revert back the negative symbol, kani negative exponent, kay dito ka nag-negative, so you can always bring it back to its location sa denominator. So negative 1 all over t plus 2t 3 halves all over 3 plus c. So kani pwede na siya. Okay? So let's go to the next example. So let's try to solve this one. So integral of x to the power 4 plus 3x to the raised to 5 times 4x cubed plus 3 with respect to x. So if you can see, so medyo struggle na siya, di ba? So kung tanawin ninyo, more the other possible way to deal with this one is to expand this one, di ba? Ano siya? Yeah, raised to the power of 5, pwede siya. Medyo lisod-lisod siya, di ba? Yeah, after expanding this particular term raised to 5, so ato po siyang i-multiply og 4x cubed plus 3. Diba? So medyo kuan siya. Medyo labad-labad siya, di ba? So for you to deal with this one is, again, kung tanawin nyo yung exponent, di ba? Yan, namatay yung base, di ba? So looking back at your basic formulas, so natay basic formula sa ato ang exponential form, di ba? So u to the power of n du. Di ba? So diri sa equation, ang ato ang n is ang 5, di ba? Ang ato ang u is kaning kuan, di ba? X to the power 4 plus 3x. So meaning ana muna atong u, di ba? Nya atong du is kaning pikas. So muna siya atong gitawag nga. So if your terms are complicated na, so going back to the formulas, so there's a technique called u substitution. So we substitute every term in your equation back to your basic formula. Di ba? Kato mga given na mga basic formula. So for you to appreciate this technique, so let's try to use different colors. Diba? So there is, we let u. So again, our n is 5 naman, di ba? So na siya dire. So our u, again, is the base of the exponent. So that's x to the power 4 plus 3x. So again, this will be our u parameter kani siya. Okay. So du, next du. So let's use another color na sad. So du, kaya na may du dire, di ba? So du na to is coming from the u parameter above. So we try to differentiate this one. So du ba over dx. Okay, x man ang other side. So by differentiating this one is we have 4x cubed plus 3, di ba? So notice nga muna siya ang term diri, 4x cubed plus 3, di ba? Yan na pa dx sa other side, kani diri dx. So para ma-achieve na nato ang iyang direct substitution, so we multiply dx on the right side. So du is equal to 4x cubed plus 3 dx. So the same yun siya dire, di ba? And this will be your du. Na, di ba? So once everything has been replaced in the equation, di ba? So natay u, natay n, natay du. So we can now use the basic formula. Okay, so we have integral. So instead of this much stuff you have to deal with, so may wala siyang u to the power of n. So u to the power of u to the power of 5 du na lang siya, di ba? So instead of kaning complicated nga equation, so you're now dealing with a basic equation. So the answer of this one is u to the power of 6 all over 6 plus c, di ba? And then, of course, we still have to bring back the value of your u parameter. So the final answer is x to the power of 4 plus 3x raised to 6 all over 6 plus c. So, muna siya inyong final answer. Diba? So, murag nakuha to ang tunok, diba? Okay, again, if you want to expand this one, kailangan pa mo Pascal's triangle. I don't know if kibawa mo ani na Pascal's triangle. Kanang kibawa mo sa mga coefficients when expanding binomials. Yeah, after using the Pascal's triangle is mag-expand pa mo ani by multiplying it by 4x cubed plus 3. So, medyo taas-taas siya, di ba? But correct gyapon siya, but muna gyapon medyo madugay mo sa pag-answer, di ba? Okay, so questions or clarifications? Hmm? Okay. Okay. Naba ka pag last meeting? Are you present last meeting or you're absent last meeting? That's why because I was asking the entire class if there's one student who don't understand Bisaya. So okay, so naday wa kasabot og Bisaya day. Okay. So for you to understand this particular technique, this U sub, so we can explain it again in the following example. So I think example 7, 8, and 9 are U sub techniques. Okay, so let's go to the next example. So the integral of x squared plus 4 raised to 7 times x with respect to x. So again, if you notice the given integrand, so this one is your given integrand. So up until x only, because again, dx is your indication of what variable you are integrating with. Okay, so notice that x squared plus 4 has an exponent of 7. Okay, so meaning if you want to make your lives even difficult, so you have to expand x squared plus 4. Then after expanding x squared plus 4 raised to 7, multiply it with x before you integrate. So again, it will take so much time for you to expand the equation. And again, in the exams, since you're only given 3 hours, so I don't think you can finish on time if you deal with expanding the equations. So again, the technique here is, again, since this one is n, and again, we base it on the basic formulas. So let's write the basic formula dealing with the exponents. So u raised to n du. So again, this technique is called u substitution. So you can look up it in Google. So there are many references in the substitution technique. Okay, so again, our aim here is to replace every parameter to the basic formula. So replace so ang n, so the n is so the n will stay intact, so it will just be 7. But what we're going to change here is the u parameter. So instead of x squared plus 4, this will become the u parameter, and then the other parts of the equation will be the du. So that's the aim of u sub. Okay, so for you to appreciate again the technique, so let's try to use another color. So again, u. So again, basing on the formula, so your u parameter is the base of the n exponent. So since 7 is the n, so the base of it is x squared plus 4. So we write x squared plus 4. So again, this particular term, x squared plus 4, is now your u parameter. Okay, so of course, what comes next is replacing it with du. So if you don't know what particular variable you're going to replace with du, so I suggest that you, so Manisha, so this is the du that we need to replace for us to achieve the basic formula. So again, if you don't know what particular functions you're going to replace with du, so what you need to do is just derive the given u parameter that you replaced earlier. So du, and then the derivative of x squared plus 4 is 2x plus 0. So again, this one is du over dx. Okay, so isolating du for us to achieve the du parameter. And of course, the other explanation for this one is for you to replace dx as well in the given integrand. Okay, so du is equivalent to 2x dx. So notice that our given integrand is x dx. I mean, what is remaining to be replaced in the equation is x dx only, because we already replaced x squared plus 4 with u, and then your 7 is your n parameter or the exponent. So what is left for us to replace or substitute is your x dx term. So this one is x dx, and then we have 2 in the equation. So for this one, for this one to be valid in replacing, so divide everything by 2. So this becomes du over 2 is equivalent to x dx. So we can now replace it above. So this one, this term is du all over 2. Okay, so if you want to practice on your own later, so I suggest you use, so if you have I forgot the Microsoft nga one, Note, I think the Microsoft Note. So you can use, or so you can use different pens, colored pens, or if you have colored pens in your house, so I suggest that you label the different parts with other colored pens for you to easily be guided in your solution. Okay, so since we replaced everything with the given variables, so we replace it. So we have u to the power of 7, and then x dx is now du all over 2. Okay, so again, the u parameter earlier, so I think you can see the labels. So that's u to the power of 7. Then this one is du all over 2. So take the constant outside the equation, take 1/2 outside the equation. So your equation becomes more simpler. So u to the power of 7 with respect to u. So integrating further, so that's 1/2. So u to the power of 8 all over 8 plus c. Okay, so that's u to the power of 8. So again, multiplying fractions, numerator against numerator, denominator against denominator. So that's u to the power of 8 all over 16 plus c. So again, don't forget to bring back the value of your u parameter, because if you don't return the value, so your credit will only be 2.0. So you're not given the full credit for your answer. So final answer is x squared plus 4 raised to 8 all over 16 plus c. So this one is your final answer. Okay, so questions so far or clarifications? Or have you appreciated the U sub technique? Okay, so if there's no question, so let's move to the next example. So this one is still on U sub. Okay, so this one. So again, the first step is you observe the given integrand. Okay, so we have a term raised to 4 and another term raised to nothing, raised to 1 only. So again, so this one is your n value, the exponent. So meaning we can achieve the basic formula of u to the power of n with respect to u. So again, for us to appreciate the solution, so we use another color. So again, the u parameter is the base of the exponent n. So in this case, the base of n is x cubed plus 6x. Okay, so this will be our u parameter. So writing u, so we have x cubed plus 6x. Okay, so what is left for us to replace is 6x squared plus 12 with respect to x, or dx. So again, since we can't verify if your answer is really 6x squared plus 12 dx, so what we need to do is we have to derive this one first, kaning u. So muna siya always derive the given u parameter, because it's paired up in the given basic formula du. So du, so we have, so that's du over dx. So that's 3x squared plus 6. Okay, so again, multiplying or isolating du, so we have du is equivalent to 3x squared plus 6 dx. So notice that in the given, or the last replaceable terms in your given equation, we have 6x squared plus 12 dx. Here in our differential of u, we have 3x squared plus 6. So it's lacking 2, di ba? So you lack 2 for us to achieve the 6x squared plus 12 na term. So what will happen next is we multiply everything by 2. So 2 here in your du, 2 also on the right side for your equation to be balanced. So you have 2 du is equivalent to 2 times 3x squared plus 6 dx. Then multiply 2 inside the equation for it to be the same as the last replaceable term in the given equation. So that's 2 du. So we have 6x squared. So multiply, diba? Plus 12 dx. Okay? So since we achieved the final form, or the same format, so you can now replace this one with 2 du. Because muna siya ang value. This is the value for the last replaceable term, 2 du. Okay, so replacing every parameter, so we now have u to the power 4 times 2 du. Okay, so factoring out 2, so the equation becomes simpler, u to the 4th du. So integrating is, the answer is 2 times u to the 5th all over 5 plus c. So again, bringing back the value of your u parameter, so that's 2 times x cubed plus 6x raised to 5 all over 5 plus c. So this is the final answer. Okay, so question so far or clarification? Okay. So another tip here is, again, if you observe the base term of the exponent n, so always notice that your u parameter, so let's put another color for you to appreciate the, okay. So again, if you observe the base term of the exponent n, so that's x cubed plus 6x, the exponent is 3. And then, so that's for the u parameter. So for the du parameter, the exponent is 2. So always take note that the degree of the u parameter is always higher compared to the du parameter. So meaning if your u parameter is, let's say this one is x squared, and then your du parameter is x cubed, so that's not possible in the u sub, because again, you'll be differentiating the u parameter, and if you differentiate this one, this will result to x only, 2x. Okay, and then you have to replace x cubed. Okay, so this one is, you have x cubed, and then when you differentiate x cubed, you get 3x squared. So of course, it's in the equation x squared. So always remember that the degree or the exponent, so if you don't know what degree is, so the exponent or the number of the exponent, or the, let's how can you say this, the value of the exponent of the u parameter is higher compared to the du parameter for you to be able to replace everything in the equation. Okay, so I think it's in the next example. So let's try the next example. Okay, so now is we have the integral of x over x squared plus 1 with respect to x. Okay, so if we look at the formula, so let's change color first. So we don't have the n parameter anymore, but we can still use the u sub technique. So looking at your equation, so we can achieve the basic formula since there are only 5. So you can use the basic formula of the natural logarithm. So du all over u. Or if you don't know the formula, so let's try to erase everything. So so let's say you don't know the formula. So I suggest that you look at the exponent. So since this one is 2 and the exponent in the numerator is 1, so automatically let this term be your u parameter. Okay, so that's x squared plus 1 because it's the higher degree or the highest exponent or the bigger exponent compared to the other term. And also notice that if you derive your x squared, it becomes x, and luckily your x is paired up with the dx parameter. So what will happen is if we try to derive this one, so du, so du over dx, so that's 2x plus 0, right? And then multiplying it to the other side, so your du is now 2x dx. So again, since this one is dx, I mean x dx only, and we have 2 here, so we have to isolate 2 to the other side for us to achieve x dx. So du all over 2 x dx. So meaning this one is your u parameter, u parameter. Then this one is your du all over 2. So replacing everything. So let's try not to use colors okay, para you'll be used to using one colored pen. So earlier I used other colored pens for a guide only. So the numerator is du all over 2 divided by the u parameter. So again, dividing fractions. So may mura siyang 1/2. So it becomes 1/2. Then we can isolate 1/2 outside the equation. So it becomes du all over u. So it becomes a much simpler equation. So answering your integral, so that's 1/2 so that's 1/2 ln of u plus c. Okay, so again, don't forget to replace the value of u again for the final answer. So that's x squared plus 1 plus c. Okay, questions or clarification? Okay, so I think there's none. So let's go to the last example. Okay, so the last example. Okay, so again, looking at your equation, so this could be your n again. N. And notice that your u parameter is squared. So the remaining term is u cube du over u cube. And again, if we try to derive your u squared, it becomes linear, u to the power of 1 only, and this one is cube. So we cannot replace this one with the the basic formula. So again, if I try to solve it on the right side, So again, your u parameter is u squared. So let's try kuan lang. So let's try z lang. So let's try z because the given equation is u. So instead of u substitution, let's call it the z substitution for this problem. So u squared plus 1. So again, if you try to get the derivative of this one, so dz all over du, that's 2u plus 0. And again, our dz will become 2u du. So meaning we can't replace your u cube. Okay? So we cannot use the the u sub here. Okay? So the other possible way here is for you to expand the numerator, because in the numerator, so since the power is only up, since it's only quadratic, so I think it's easy for you to expand the equation, diba? So expanding the equation, so integral of u squared plus 1, u squared plus 1 all over u cubed du. Okay? So earlier, it's impossible for you to expand because it's raised to fifth power, raised to seventh power. But in this example, so we can just expand this one since it's only raised to 2. And again, we cannot use the u sub technique because we cannot replace every term in the equation. So u raised to fourth plus 2u squared plus 1 all over u cubed. Okay, so du. Then since the numerator has 3 terms and it's divided by 1 term, so you can isolate every term in the equation, or you can break it down further, even further. So u to the power 4 over u cubed plus 2u squared all over u cubed plus 1 all over u cubed du. Okay, simplifying further is we have u to the power 4, then 3. So what is left is u du. So I automatically distributed du to the first term plus the second term. So taking 2 outside the integral symbol. So 2 against a. So what is left is du all over u. Then lastly is integral of du all over u cubed. Okay, so integrating, so you have u squared all over 2 plus 2 ln of u plus, so instead of plus, this becomes minus. So I'll just um, create a shortcut because it's almost time. So minus 1 all over 2 u squared plus c. So just review the recording later for you to be able to process the other steps in this example. Okay, in summary, most likely when you deal with problems later on, it's more of a trial and error method because um, you don't really know that this particular method works with the given integral. So if this particular process um, doesn't work, so you need to try another method. So if so again, if the next method doesn't work, so you need to find another method So I think that's all. So go very basic with each problem. So don't overcomplicate yourselves with answering such complicated problems because those complicated problems can be approached using basic methods. Okay, so questions or clarifications? Okay, so if there's none, so let's meet again this Friday for the next lesson.